Hi, welcome to the next lecture of the series where we are going to understand how can we simulate digital circuits using the softwares, and we can see the behavior of different logic circuits. So in the this is the second lecture in the same series, and in this series what we are going to do is like we are going to implement XNOR gate from NOR gate. So it's like basically in the logic gates we have two kinds of gates which are known as universal logic gates, and that is NAND gate and NOR gate. So in this video what we will do, we will try to see what are the step by step procedure to implement XOR gate. Here we will implement XOR gate by using NOR gate. Okay, so let's start it. Let's get started now. So look, our task, what is our agenda? Agenda is to implement XOR gate when we are given with a NOR gate. So this is the gate, this gate is given to us, NOR gate is given to us, and we need to implement XOR gate, okay, by using NOR gates. So for NOR gate we know that the output is, this is the symbol of NOR gate, and the output is given as, suppose A and B are your inputs, then output will be A plus B whole bar. Okay, so but in XOR gate, suppose A and B are your input, so this is how XOR gate looks like. Your output will be A B bar plus A bar B. Okay, so our first step will be to implement this, okay, A B bar, and then in the second step we will implement this. So in 3/4 steps we will do the complete implementation of XOR gate. So see, you are given with A, like first step is to generate AB bar. Now AB bar, how can we generate, is by doing so. So you just give A to the same NAND gate in the both the inputs. So both the inputs of this NAND gate, so let me say like it's, suppose this is A1, okay, A1 means this is just logic gate 1, let's say. So this is A1 and this is A2, let's say. Okay, so for A1, if we will give both the inputs as A, then output will be, how will be the output? It will be like A plus A bar. Yeah, it will be A plus A bar. So A plus A bar is how much? What? A bar. So here we are getting A bar, and here we will be giving B. Now the output of this NOR gate A2 will be A bar, because A bar is coming here, plus B whole bar, and it will be A B bar. So in this way what we have done, we have implemented A B bar. This is done. Now similarly we can implement this also. So we can implement this also, and we will get A bar B. Now the next step is to get this expression, is to sum them. What we can do for that? So this input and this input we can give here and here, okay, and we will pass it through another NOR gate. Let's call it A1 A2, this will be A3, and this you say A4, A5 and A6. So we will pass this input to A5, and there our output will be this much, this. But what we want to implement is this. Yeah, so how can we implement it? So we need to remove this bar. For that we will again pass it through the NOR gate only by shorting the two inputs, and we will get the desired output. So this is how we can implement this XNOR gate by using NOR gate. So what we will do, this whole circuit, so this, now we will implement in the LT spice. We will try to simulate it. We will check whether this circuit, whatever we have derived or made, is it really working or not. Okay, so for that, so this is LT spice. This is LT spice. In the LT spice, we have created two voltage sources, V1 and V2. Okay, yeah, so we have created two voltage sources, V1 and V2. And how to create this voltage source? This is our digital voltage source, and how can we create it? I have already mentioned in the previous lecture. Okay, we can just put a voltage source and set it to be pulse. So our first step is to implement this circuit. So let's finish step 1. So you just right click. We need to implement this portion. Right click, go to draft components and OR gate. You can just type OR here, this gate will come. So this is for A1, this is for A2. Yeah, similarly we will first put all the components. We need A3 and A4 also. So just you can duplicate this also. Edit, duplicate. This is A3 and again this will be A4. Now we can go here. This is your A5 and this is your A6. Let's connect the wires now. Edit, draft wires. So look, we need to make A1. So A, this is A, this is B. So connect A to A1 and it should be at both the inputs. Yeah, then you connect the output. This is the output of XOR. The top one, this one is normal OR. This is the inverted OR, means NOR. So you just give it here, and so this is A bar. Now B should be connected to A2. B is connected to A2 now. So this is step 1 is done. Now step 2. Step 2 means A3 we should give B twice. So this is B and this is also B. Okay, this is done. Now we need to give here, we should connect A. So we will connect A, yeah, and this output should go here. Done. Now this should be connected to A5 and this should be connected to A4 and this is going to A6 here. Yeah, A5 is done. Now output of A5 should go to A6 with 2 inputs. Now this will be your output. Label it as out. This is output because these two are inputs. Okay, like now what is the next step? Just save it, file, save it. Now right click and run it. Okay, we want to see the results, so I will just minimize this window. This window also we can minimize for now. Yeah, now we need what we will see here. Here we want to see 3 waveforms, A, B and the output. So add one more plot plane. You click here, then if you come here, you will see the test point A Okay, then again you B, here you click and here you show this output. Yeah, so you are getting your output. Now let's focus, let's try to understand this waveform. So this is A, this is B, this is output. Output means XOR of A and B. Now how can we verify this? See, what is the truth table for XOR gate? So truth table is like A and B are your input and this is your output. Output is A plus B bar. Okay, so see, for XOR, so this is time, these are the voltages. So for time 0 to 0.5 seconds, so between 0 to 0.5 seconds, this one 0 to 0.5 seconds, what are the inputs? See here, your A is 1 and B is 0. It means we are in this section. A is 1 and B is 0. Okay, this is for time 0 to 0.5. Yeah, your output should be 1 and your output is 1. So this is true. Now between 0.5 to 1, what is the state? 0.5 to 1, our A is 1 and B is also 1. Both are 1. Both are 1 means we are here. Okay, and when both are 1s, then what output we should get? We should get 0. So we are getting 0. Again from 1 to 1.5, your A is 0 and B is 1, means A is 0, B is 1, we are here. So 1.5 to 5, for this case we should get high and we are getting high, we are getting 1. Okay, similarly between 1.5 to 2 seconds, A is 0 and B is also 0, so we are here. So in this case what we have seen, all the our truth table, our truth table, like our truth table for XOR, we are able to achieve this by using this circuit. It means this circuit is working good, and this is how we can implement XOR gate by using NOR gates. So we can implement other circuits also by using the same technique. We can implement the same by using the same technique. We can implement other gates also. For example, I will just show you. See here, if you see, we are implementing a NOT gate. We are giving the same input and getting the inverted out. This is NOT gate. And if you see here, we are implementing the ending operation. So this is ending operation also. Okay, so this is how we can implement. Thank you so much. Take care. Bye bye.